to a matrix from normal, where the normal is the get normal. This function returns the vertex normal at the indexed vertex from the mesh, and v is the index of the current vertex. At this point, the clone would be placed at the word origin and rotated to look with its z-axis, local z-axis, along the vertex normal, but the translation part, the row 4, would be 0, so as next step we would have to set the position of this clone to the actual coordinate of the mesh vertex. If we would like to be able to move the main object, the T.01, and have all the clones following that motion, we can assign the target, which is the distribution surface, to the parent property of the clone, thus linking all the clones residing on the vertices to the distribution surface. Now we could try to evaluate this script, and we get a single teapot on every vertex of the distribution mesh. Since those objects are instances, we could again change the radius, and all the objects would be changed automatically, including the original source. If we would change the step to by 2, for example, we could evaluate again. The old clones will be deleted. New ones will be created on every second vertex. If you would take a closer look at the result of the script that we created in the previous lesson, you will notice that while the z-axis is following exactly the vertex normal at the surface, the x and y, and especially the rotation, the orientation of the x and y axis relative to z, are pretty random. They're not really random, they are being calculated internally to follow certain rules, but in this case we would like to have every single object which is at a certain level of the surface to have the same orientation, no matter which quadrant, which side of the word coordinate space its vertex resides in. In order to do this, we would have to introduce a up vector which defines a major direction for the orientation and tells the objects how to rotate, and we're going to build our own matrix tree value instead of using matrix from normal. Most of this script can be left as it is. That means we are going to delete all the previous clones, define variables to contain the surface and the source, snapshot a copy of the mesh in memory, go through all the vertices, create instances for every single vertex, set the name. But now, instead of assigning the matrix from normal result to the transformation matrix, we're going to first grab the normal vector from the current vertex and find one vector which we'll call the x. This is the future x-axis of our transformation matrix, or the row 1, which is the normalized result from the cross product of the normal and an up vector, which we could take as the word vector 001, which would be up, or we could use the source direction property. The source direction would be, if we would select the